title of your notes today, Formal Definition of a derivative. Alright, so let's review first. Alright, when we find the derivative, or f prime of c, what are we finding? The slope at that specific x equals c value. And so we can say the instantaneous rate of change of f of x with respect to x at x equals c. That's what it means when I'm finding f prime of c. And I know f prime of c the derivative of this function at point C equals the slope of the tangent line to the graph of this function at C. And our main formula that we use for the derivative at that one point, f prime of c is equal to the limit as x approaches c of f of x minus f of c over x minus c. Okay, so now what we want to do is consider finding the derivative of f of x at any value of x. So not just at one point, but at any value. And so let's review with a curve. And we'll put 2 points on our curve. So we have point P and we have point Q. And let's define point Q as well, first let's define point P as x comma f of x. And now I know if I go from P to Q, that's going to be some different change in my x's. My x's are changing. So now I'm going to define point Q as x plus the change in x. And if I want to find my y value, then I would just plug that into it. So f of x plus the change in x. Okay. So do we get how we defined our point Q?
Mm-hmm.
We're just showing that this would be this x value plus whatever the difference is from here to here. Alright, so what would the slope of the secant line be? So slope of the secant line PQ. We could just use our rise over our run, our y2 minus our y1 over x2 minus x1. It's just the slope of a line with 2 points, right? So that would give us y2 would be this f of x plus the change in x minus y1 would be f of x over x2 would be x plus the change in x minus x. x2 minus x1. So nothing there changes from how we found the slope before. We're just defining our points a different way. When we found the derivative at a point, what did we say? Why did we take the limit as x approaches that x value? Because it was going from the secant line to the tangent line. And we knew the instantaneous rate of change was a better approximate than the average rate of change. So as we move now from the secant line to the tangent line, what's happening to my change in x? It's getting smaller until eventually there's no difference. So it would be approaching what? What's the difference approaching as I get closer and closer? 0. Okay. So what happens to the equation as the change in x approaches 0? It becomes closer and closer to my tangent line. Goes from a secant line to the tangent line. And so the derivative f prime of x, so now it's no longer at a certain point, but the derivative of f prime of x of a function f of x is the function defined by and here's our formula. F prime of x, this is the formal definition of the derivative, how we titled our notes. F prime of x is equal to the limit as the change in x approaches 0 of f of x plus the change in x minus f of x, and before I write the bottom, up here if I simplify it, x minus x goes away, and it's just over the change in x. So this is our formal definition of the derivative. And that's how we find the derivative of a function and not just the derivative at a point. Alright, so before we do some examples, let's let's talk about some different notations, and then we'll see how we use that. So derivative notation. So we have f prime of x, which is the derivative of f of x. You could write it as dy over dx, and it's still the derivative, but it's the derivative of y with respect to x. We can see it wrote as y prom, and that's just, we're not in function notation. They just wrote our equation as y equals, so it's the derivative of y. So those are different notations you may see. Okay, so example 1. Find the derivative of f of x equals x squared plus 2x using the formal definition. So I'm finding the derivative of f of x using the formal definition. So my formal definition is f prime of x is equal to the limit as the change in x is approaching 0 of f of x plus the change in x minus f of x over the change in x. Okay, so I need to figure out what is f of x plus the change in x. And that's just plugging into my equation. My input is x plus the change in x. So wherever I see an x, that's what I'm plugging in. So I'll rewrite it as x plus the change in x squared plus 2 times x plus the change in x. So plugging in to our function. Y'all remember doing this in pre-cal? Alright, so right here I have a binomial squared, so I have to expand it and FOIL it. And then over here, 2 times x plus the change in x, I can go ahead and distribute the 2. So that gives us plus 2 times x plus 2 times the change in x. Alright, so now let's FOIL. So first, x times x is x squared. And then my inner and outer terms, I'm going to have x times, we'll just go ahead and write it out. So my inner terms, I have x times the change in x, and then same thing with my outer terms, x plus the change in x. And then my last term, the change in x times the change in x, would be plus the change in x squared. And then plus 2x plus 2 times the change in x. So now combining these terms, we can write it as x squared plus 2x change in x. And then none of these other terms are alike. So plus the change in x squared plus 2x plus 2 change in x. So that's what we're going to plug in for f of x plus the change in x. Okay, so now let's start it. F prime of x is equal to the limit as the change in x approaches 0 of f of x plus the change in x, so we're plugging in what we just got, and I'll plug it in parentheses to start with. So x squared plus 2x times the change in x, plus the change in x squared, plus 2x, plus 2 times the change in x, minus f of x, so make sure you put it in parentheses, and f of x is x squared plus 2x, and then all over the change in x. And let's pause right here and let's think about, what am I trying to do to evaluate this limit? I'm trying to direct substitute 0 into my equation with the limits of. I can't do that right now because I can't have 0 in the denominator. So we're trying to simplify this to where we can divide out that change in x. So we're going to go through the algebraic process of simplifying this until we've pulled out a change in x and top and we can cancel it out. Okay, so we'll write out step by step this time because it's our first time, but eventually you could see that x squared minus x squared would cancel out. But for now, I'm just going to go through that step of distributing my minus sign. So I'm going to rewrite the top without parentheses, x squared plus 2x change in x plus change in x squared plus 2x plus 2 change in x, and now distribute the minus sign. So minus x squared, and then negative times positive 2x makes negative 2x. All over the change in x. So now combine like terms. So I have x squared minus x squared, that goes away. I have 2x minus 2x. Oh wait, that's, I gotta be careful there. So here's my 2x minus 2x. So now this gives me f prime of x is equal to the limit as the change in x approaches 0 of 2x times the change in x plus the change in x squared plus 2 change of x over the change of x. So do you see how everything, the x squared went away and the 2x went away? And I know I'm on the right track because now I only have terms with change in x left in them. And that's going to get me what I need is to be able to factor out the change in x. So factor out the change in x now. So when I take it out of all those terms on the top, I'm left with 2x plus the change in x. I took one out, so I'm left with just the change in x. Plus, if I factor the change in x out of 2 change in x, I'm left with just 2. It's like dividing each term by the change in x. All over the change in x. So now if I divide it out, I now have f prime of x equals the limit of the change in x as the change in x approaches 0 of 2x plus the change of x plus 2. Now I can use direct substitution. And if I plug 0 in, I get 2x plus 0 plus 2. So f prime of x is equal to 2x plus 2.